Hey there. This is Dynamics Worksheet number 2, question number 1. In this question, we have a 4 kilogram block which is initially at rest on a rough table, which is being pulled to the right by a horizontal string which exerts 25 newtons of force for a total of 4 seconds. We know the coefficient of kinetic friction between the block and the table is 0.25, and our job is to figure out the final velocity of this block. So obviously, the first thing I would do here is draw a free body diagram. There's a block. Obviously it has weight, so force of gravity pulls it down. We're told that the string pulls it to the right, and we know the force the string exerts is 25 newtons. It is on a table, and that tells me that there's got to be a normal force holding it up. And then because there is a coefficient of friction mentioned, there's probably going to be a frictional force, and since we're pulling this block to the right, friction is going to oppose the relative motion between the surfaces, so it's going to go to the left. The next thing that I can do is draw or write a net force equation. Since this is accelerating the x direction, I'm going to start with a x net force equation, and I'm just going to do rights minus lefts, so tension minus the frictional force. Since I already know the force of tension, I don't have to do anything there. It's 25 newtons, but I don't know how big the frictional force is. So in order to find the frictional force, I need to find the normal force, and so a net force in the y direction equation would help me do that. So I'm going to write something like net force equals normal force minus the weight, ups minus downs. Since the block is not moving up or down, I can say that the forces in the y direction are balanced, even though the forces in the x direction are not. So since the forces in the y direction are balanced, the normal force just equals the weight, which I can find by multiplying mass by the gravitational field, which would give me a value of 40 newtons for the normal force. That's important because I know that the force of friction is equal to mu, the coefficient of friction, times the normal force. And so multiplying the 0.25 by the normal force of 40 newtons lets me figure out that the frictional force is 10 newtons. So now that I know the frictional force and I know the tension force, I can figure out the sum of the forces in the x direction. So I would just subtract 25 newtons minus 10 newtons, which would give me 15 newtons. So the sum of all the forces on this block is 15 newtons, and it's helpful to note that that is to the right. It's being pulled to the right, its net force is to the right, so it must be speeding up while moving to the right. The next thing that I can use is Newton's second law, just the fact that acceleration is net force divided by mass. I've got a net force of 15 newtons, a mass of 4 kilograms, which gives me an acceleration of 3.75 meters per second squared. Now that I know the acceleration of the block, I can use our motion equation, v equals v naught plus at, or a equals delta v over delta t. Those are two different ways of saying the same thing, to figure out the final velocity. I know that this thing starts at rest, so its initial velocity is 0. We found the acceleration just now to be 3.75 meters per second squared, and we're asked to do this for 4 seconds. So all I got to do is multiply the acceleration by the time, and that would give me a value of 15 meters per second. It might also be helpful to note that that direction of that velocity is to the right. Remember that a vector such as a velocity has not only a magnitude but also a direction, and so it's just important to note what that direction is. That's all for now. Da-da.